I'll make this topic super easy. Click the subscribe button below and watch this lecture until the end. STP. S stands for standard. T stands for temperature. P stands for pressure. At STP, the value of temperature is 0 degrees Celsius and the value of pressure is 1 atmosphere. At STP, 1 mole of any gas occupies 22.4 liter. This volume known as molar volume. Let me give you different example. 1 mole of hydrogen molecule, which is equal to 22.4 liters. 1 mole of nitrogen molecule occupies 22.4 liter. 1 mole of carbon dioxide occupies 22.4 liters. 1 mole of methane occupies 22.4 liters. 1 mole of argon occupies 22.4 liters. Avogadro's law states that equal volume of different gases, they are different gas but equal in volume at a constant temperature and pressure, contains the same number of molecules or moles. Mathematically, Avogadro's law states that moles or molecules of a gas is directly proportional to the volume of the gas at a constant temperature and pressure. Volume problem. What volume of oxygen will react with methane to produce 44.8 liter of carbon dioxide at STP? Look, the question here is that the volume of oxygen and the given quantity here is the volume of carbon dioxide, which is equal to 44.8 liters. So we are going to determine the volume of oxygen. Now let us write the chemical equation of this word equation. Methane react with oxygen to form carbon dioxide and water. Now this chemical equation is unbalanced chemical equation. So let us balance this chemical equation. On the reactant side we have one carbon and in the product side we have one carbon. So carbon is balanced. In the reactant side we have 4 hydrogen, but in the product side we have 2 hydrogen. Therefore we put coefficient 2 in front of water, and at the same time we put the coefficient 2 in front of oxygen molecule. Now the equation is balanced. Let us check it. We have one carbon atom in the reactant side, and again we have one carbon in the product side. We have 4 hydrogen in the reactant side. Again we have 4 hydrogen in the product side. 4 oxygen in the product side. Now the question is that to produce 44.8 liter of carbon dioxide, our purpose is producing for 44.8 liters of carbon dioxide. How many volume of oxygen, how many liter of oxygen molecules are required? To solve this problem, let us set up oxygen molecule to carbon dioxide molecule ratio. 2 mole of oxygen molecule produce 1 mole of carbon dioxide, means that 44.8 liter of oxygen molecules produce 22.4 liters of carbon dioxide, or for 22.4 liter of carbon dioxide produced from 44.8 liters of oxygen. Now the question here is that to produce 44.8 liter of carbon dioxide, how many liters of oxygen required? Let's say this is Y. Now to determine Y, let us cross 44.8 liters into 44.8 liters, which is equal to Y into 22.4 liters. 44.8 liters into 44.8 liters equal to Y into 22.4 liters. Now divided both sides by 22.4 liters, again by 22.4 liters. After calculation we have Y equal to 89.6 liter of oxygen is needed to produce 44.8 liters. Don't forget, to produce 44.8 liters of carbon dioxide, we must need 89.6 liters of oxygen molecule. Mass volume problem. How many grams of magnesium should react with sulfuric acid to produce 5.6 liters of hydrogen molecule at SCTP? Listen me carefully. Look this question carefully. Just the question here is that to determine the mass of magnesium, and the given quantity is that the volume of hydrogen molecule, which is equal to 5.6 liter of hydrogen. To produce 5.6 liter of hydrogen, how many grams of magnesium is required? The question is that one. Let us write the chemical equation here. Magnesium reacts with sulfuric acid to produce magnesium sulfate plus hydrogen. Now this chemical equation is balanced by itself. Now the question here is that, as I told you, to produce 5.6 liter of hydrogen molecule, how many grams of magnesium is required? This is the question. This is the mass of magnesium that used to produce 5.6 liter of hydrogen. So let us set up proportion magnesium to hydrogen molecules. The given one to the required one. 20 gram of magnesium, which is atomic mass of magnesium, produce 22.4 liters of hydrogen gas. This is from balanced chemical equation. 24 gram of magnesium is required to produce 22.4 liter of hydrogen molecule. The question here is that to produce 5.6 liter hydrogen molecule, how many grams of magnesium is required? This is a question. Yes, to produce 22.4 liters, we require 24 grams of magnesium. And to produce 5.6 liter of hydrogen, how many grams of magnesium are required? Let's say that's Y. Now let us cross. 5.6 liter into 24 gram, which is equal to Y into 22.4 liters. 134.4 gram liter, which equal to Y into 22.4 liters. Now let us divide both sides by 22.4 liters. 22.4 liter by 24 liters cancel each other. And at the end of the day, we have Y equal to 6 grams of magnesium needed. Listen me carefully. Just 24 grams required to produce 22.4 liters. 6 grams of magnesium needed to produce 5.6 liters of hydrogen gas. So the value of Y is here is